Once you've looked over your partner's paper, hand it back to them. Give them any feedback if you haven't already, as far as, yeah, I agree with what you did, no, I think you did something wrong here. All right, so before break, we did a ton of work with sine, cosine, and tangent. And being able to use those to find either missing angles or missing sides. So I just picked 3 of the examples that either you or your partner did. And each one, there's an example of a sine up there, there's an example of a cosine, there's an example of a tangent. So if I said, okay, which one of those, A, B, or C, is an example where you had to use sine? Which of those had to use sine of those 3 examples that I put up there? Well,
I see.
Yep, C would be one where we had to use sine. The setup for this one should have been the sine of 32 degrees would equal the opposite side of x over 5 hypotenuse of 19. So that would be one where we had to use sine. Okay, what was an example we had to use cosine? That's up there. Show. Which one, I'm sorry? B, yeah, B was going to be a cosine example. Cosine of 63 would be the adjacent side of 48 over x, okay? And then the last one was an example of tangent. Part A was an example of tangent. For the tangent of 32 is equal to 15 over x. Those have been the equations you should have used. And then remember, trying to solve those, we usually put them over 1 to help us out. And sometimes when I cross multiply, I have my answer right away. Other times I have to take the extra step of dividing. Well, which one of those would I have my answer right away when I cross multiply? Yeah, C, I'd have right away. So once I plug that in, you should have, if you did that one, ended up with about 10.07 credit at all. The other 2, though, when I cross multiply, I don't quite have my answer yet. Because I'm going to have tangent of 32 times x, and that equals 15. So you had to end up dividing on that one. So to get my answer, I'm going to take 15 divided by the tangent of 32. So if you did that one, you should have gotten about 24.01 or 24. And then that middle one would also be a division problem. And some of you are starting to notice if I have x in the denominator, in order to find x, we have to do some division. In this case, we're going to end up dividing by that cosine of 63. So when you type that one in, you should have 105.73. All right, so hopefully those kind of ring a bell from what we're doing before. And then toward the end of last week, or the week that we were here, we started talking about special right triangles. We threw in the 45, 45, 90 right triangles. And we said they had this relationship. And we had the 30, 60, 90. And those we said had this relationship. So keeping those things in mind, and you can do this on the back of that sheet if you want to. But I've got two figures up here. And for each of the figures, I want you to find both the area and the perimeter of the figures. So you're going to try to find the area and find the perimeter for each of those two figures. And when you do that, you're going to see, in some cases at least, that these two may pop up somewhere and be helpful. On part A, which one was easier to find, area or perimeter?
Perimeter.
Yeah, perimeter on that one because we knew all of them, right? They said that they were all the same, so we didn't have to do any extra work. So what do we have? 5 of them there, so you should have a perimeter of 30. Which is that one. Okay. Area was a little more difficult because we had to find a little bit extra. But it actually worked out fairly nicely because we knew this had to be the same length as that. So we knew the base there was 6, which means, even though it kind of looked like a rectangle, this is really a square. So I can find that area pretty quickly. What about the triangle, though? How did you figure out the area of the triangle on that one? Daniel, what did you do?
Well, first you have to find the height.
Okay.
So, to find the height, I did 6 squared plus b squared equals Or 3 squared plus b squared equals 6 squared.
Okay, there's nothing wrong with that. So there's one option. All right. Is there another option? And we'll come back to what your value was there. Is there another option for finding that height there? Isaac?
Well, we know that it's 3 to
Okay, because if I really drew that height in, it's going to cut it in half, which makes it a 30, 60, 90 over here. So that's going to be 3 times the square root of 3 for the height, which if you did your method, you'd get the decimal amount for that. But in any case, I now have enough information to figure out what the area is. So if I did the base, which was 6, times now the height, which is 3 square roots of 3, divide that by 2, I find out it's about 15.6. So when I put that together with the 36, you should have had somewhere around 51.6 ranges on that. All right. What about part B? We know some pieces that are the same. I drew in this red line, which the reason I did that is I know it has to be the same as that. Plus, if I have all 4 90-degree angles and 3 of the sides are the same, that means this one has to be the same as well. So I've got a square again. The question is, can I find one of the sides of this square? How do you find that, Michelle?
We have 45, 45, 90 triangle.
Uh-huh.
We did 6 to square and 2, 6 is in the next place. But
Right.
it's right at this point.
Good. So that means both of these sides had to be 6, which means all these had to be 6. So as far as the perimeter is concerned, I can add those up. So I got 12, another 12, so that's 24, plus that 6 squared to 2. So if I want the decimal amount, I can add all that together. So your perimeter should have been about 32.5. And then if we look at the area, this would be 36. What would be the area of that triangle? Or the base of the height? Yeah, 6 times 6, so 36, but we got to divide it by 2,
18.
18. So when we put it together, should have 54 square centimeters. Okay? So using your special right triangles helped out on that. All right, so we did all this work with all the different options or sines or cosines or tangents. We didn't do a Pythagorean theorem problem necessarily here, but we had that as an option. And then we threw in our special right triangles. But so far, all of our options have been surrounding things that are right triangles. What we haven't been able to attack yet is something like this, where I'm given this information, and I want to find the length of side B. So I know about 2 of the angles right now. I know one of the sides over here, but I want to find this other side. And I may look at those 2 angles and think, well, maybe if it's a right triangle, I can use some of these options that we've been talking about. But I add the 59 and the 38 together, and I see what I have left, and I find out that I have only 83 degrees left for this angle. So I don't have a right triangle. And right now, I don't have great options if I don't have a right triangle. However, we did do some problems that were kind of like this. What we say an option might be for this one and help us to eventually figure out how long B is going to be for this one. What do we do?
You could draw a line from corner C down to the hypotenuse.
Yeah, I want to make that what kind of angle?
Or make that a 90 degree.
Right. So maybe I could do that. Maybe I could draw in that height and try to use that to help us out. Because over here on the right side, at least, I've got an angle and I've got a side. So I could use that information maybe to figure out what the height is. So let's do that. Let's figure out what the height is on this one. Well, should I be looking at using a sine, a cosine, or a tangent based on that picture on the right-hand side?
Cosine.
Which one?
Cosine.
This one, though, it's going to be sine. Yeah, it's going to be the opposite. And I'm missing over the hypotenuse. So I can find h by looking at the sine of 38. Because the sine of 38 should be that h over 350. So let's see what h is. This one is one of those where when I cross multiply, I'll get my answer. So 350 times the sine of 38 gives me 215 and a half. So now I know this side. How can I use that to help me figure out what B has for a length? If I focus on that triangle on the left. Well, I could do Pythagorean theorem to find this piece, but remember our goal here eventually is to find this piece. And maybe having that little piece over there is helpful, but could I maybe just go directly to trying to figure out what B is now? Yeah, what can I use if I focus on just this one over here? Yeah, back to sine again, right? So I can do the sine of 59 this time because I got the angle over here. That should equal that side I just found over the side that I missed. Now this is one of those where eventually we'll divide once I cross multiply. So to get this value, I'm going to take that value I just got, divide it by the sine of 59, and I get my answer for B. So it wasn't awful. We had to draw in that height. We had to do 2 problems to find it. But it sure would be nice if we had a faster way to get there, instead of having to make it our 2 right triangles. Well, the method we're going to look at today is going to allow us to attack this problem without creating 2 right triangles. So I'm going to show you some steps here. Now, you don't have to write these steps down until we get to the final step. Basically, I've got the same picture that I just gave you, except now instead of giving values, I just labeled it with A, B we were already missing earlier, and I labeled that with H, just like I did before. Well, a second ago, we worked on this side. We said, well, to find H, I could do the sine of angle B, and that was H over A. And then once I dealt with that, I went over to this triangle, and I dealt with H again. I said, well, the sine of A is equal to H over B. But in both triangles, I used what value? Which value did I use both times? One time I found it, and the other time I used it. The height. Yeah, the height of the triangle. So I'm going to try to get the height of the triangle here and the height of the triangle here isolated. Or in other words, I'm going to get rid of the fraction. So over here, I have the height is equal to A times the sine of B. Over here, if I get the fraction by itself, the height is equal to B times the sine of A. Well, did that height change from one triangle to the other, or was it the same length? The same length, right? That didn't change. So that means the H here is the same as the H here, which means I could say this, A times the sine of B is equal to B times the sine of A. Well, I've got A's and B's all over the place, so to kind of clean it up a little bit, I'm going to get anything with A on one side. So I'm going to get this A to the other side. And anything with B, I want it on the together, so I'm going to bring this B to that side. And the result is what we're going to focus on. We end up with this proportion, where the sine of angle A over side A is equal to the sine of angle B over side B. And this result has a special name. This is what's referred to as the law of sines. Where if we take the sine of any angle over the side that's across from it, that's the same as looking at the sine of a different angle and the side across from it. And the nice thing about law of sines is I can use that for any triangle. It doesn't have to be a right triangle. So So if I'm stuck with a triangle that's not a right triangle, I can still use law of sines. And we'll put that in our triangle toolkit here in a little bit. So I could go back to that problem we just did, and I could have answered that a lot faster. Because as long as I know an angle and the side across from it, like I have 59 degrees and this side across from it, the law of sines said you can do the sine of 59 over the opposite side, and that should be equal to this angle over that opposite side. So the sine of 38 over that opposite side. So if I use law of sines, it would look like that. Well, sine of 59 I can do on the calculator. Sine of 38 I can do on the calculator. So now I really just need to cross multiply. So if I were to cross multiply, I'm looking at the sine of 59 times b. And it should be equal to 350 times the sine of 38. Which means in order to find b, all I have to do is divide. And from there, it's just a matter of typing that in. So if I type all that in, I would hopefully end up with the same value that we got earlier. So law of sines says we can do the sine of any side or any angle over its opposite side, and that should be equal to the sine of any other angle over its opposite side. And that works again for any triangle that we want to look at. This was that extra credit problem that a lot of you tried the other day, and I handed that back to you. And a lot of you showed some really good steps, and there are a lot of different things that you had to do to solve this one. However, if we would have known about law of sines, it would have been a lot faster. So let's see how we could have used law of sines to figure out this information. Well, first of all, could I find the third angle there in that picture?
Yes.
Yeah, how?
You add up 29 and 48, and then you subtract that sum from 180.
Right. And in this case, we end up with 103 degrees on that one. Well, as soon as I see I have an angle in the side across from it, that tells me I can use law of sines. So I have that angle of 103 degrees. So I can say the sine of 103 over its opposite side is 5, is equal to, now let's say I wanted to find a side x. What angle should I be using if I'm going to find x on that one? Yeah, the one across from it. So I'm going to say the sine of 48 over x. And so now I'll do my cross multiplying and figure out what x is. So sine of 103 times x should equal 5 times the sine of 48. So in order to find x, I need to divide by that sine of 103. So go ahead and type that in, because sometimes just typing it in correctly is the hardest part. But go ahead and type in 5 times the sine of 48, and then divide that by the sine of 103, and we'll make sure that everybody's getting the same value. The key to this is making sure that you close your parentheses at the correct time. So like if I do 5 times the sine of 48, you're gonna have to close those parentheses before you do your division. When I divide it by the sine of 103, you should have gotten 3.81. Sometimes to avoid that mistake, what I'll do is I'll do 5 times the sine of 48. I'll hit enter before I do my division. I'll do that, and I'll divide by the sine of 103. But in either case, I should get that same answer. All right, so why don't you guys see if you can find y. See if you can use the law of sines and figure out what y is.
Yeah, we're gonna end this one too. Something might be good. Yeah, that's fine.
If you enter it in correctly, you should have ended up with 2.49. If we're at that. So a nice way to attack problems if we're not lucky enough to have a right triangle. So let's add this to our toolkit. So we have our 7th option now. So our next tool is going to be our law of sines. So what do we need? Well, we have to know an angle and the side across from it. If I don't have that, I can't use law of sines. So I have to have an angle, and I have to know the side across from an angle. Then after that, I just need one other piece of information, either one other angle or one other side. So I need to know at least one other angle or side. So for the example, general notation, the capital letters will be for angles. The side across from those would be lowercase. And so we know the sine of angle A over A should be equal to the sine of angle B over B. Now, I could use angle C as well. If I wanted to say the sine of angle C over C, that works as well. But any two angles you can use, as long as you know one of the angles in the side across. So if we know we don't have a right triangle, I can go straight, at least right now, to the law of sines. Now we do have that eighth option that we'll talk about tomorrow. And then guess what it is? We got law of sines.
Law of
Oh, the other one. Cosines, yep. Law of cosines. So we'll talk about law of cosines tomorrow and how we would use that. Now I want to go through one other example, and then I'm going to have you guys try some different things with law of sines. So far we've had missing sides in our picture. What if I have a missing angle in my picture? Can I still use law of sines? Well, I look at this picture here, and I notice they gave me two sides, and they gave me one angle, but I got to find the other two angles. Well, as long as I know an angle and the side across from it, I'm in good shape for law of sines. So that tells me I can use law of sines here. So I have the sine of 48 that I can put over 32. And that should be equal to the sine of any other angle over its opposite side. But all I have is this other side here of 26. So the angle I'm going to deal with is this angle right here, angle P. So the sine of angle P over 26 is the second part of my setup here. Now this is going to be a little bit different because I really don't want to go to cross multiplying on this. Because my goal, remember, is to figure out what the sine of P is, or what the angle measure for P is. So I'm going to try to get sine of P by itself. So I'm going to do that by getting rid of this fraction over here. So I'm going to multiply both sides by 26. So the sine of P is going to be equal to some value here. So let's see what that value would be. Well, if I type in this 26 times the sine of 48, and I divide that by 32, I get 6038. But that's not my angle measure. How did we find the angle measure when I was trying to work backwards? What did we have to do on the calculator to find the angle measure? Claire?
Negative.
Yeah, do that inverse, the negative. Looks like a little negative exponent. So I'm going to do the inverse sine of that decimal of 0.6038. And when I do that, I get 37.1, so I'm going to round it to the nearest whole number. And angle P is 37 degrees. Well, they also want me to find Q, but the good thing is I've already got two angles, so now I can find the third one. So if I add those two together, we have, what, 85? So that's going to leave me with 95 degrees. So law of sines can help us find missing sides, but sometimes we're going to use it to find missing angles as well. All right, well, we're going to practice some situations where law of sines might pop up, or maybe you have to use one of our previous options to help you on that. So what I'm going to have you do is I'm going to have you move into what will be your new groups. So your new groups are basically in groups of 4 for most of you. I guess it's people today, so somebody will be just partnered up. But you 4 be in a group, you 4 here, you 4 here. Primarily, it'll have 4 here, 4 there. All right, go ahead and turn your guys if you would. Introduce yourself if you don't know everybody in your group.
Mine is now. Hi, nice to meet you.